Hello, this is my lab for my video lab for lab 3, the free fall of an object. So, this lab pertains to the free fall of an object, a cleaning cloth in my video, and the modeling of its free fall using gravity as its only force, and then using drag as one of the upward forces acting upon it. We'll be comparing both models to the original, and we'll explain why one is better and why they're both slightly off. So, some background, we'll be using Newton's second law to find the object's position and velocity using the position update and velocity update formulas. We'll also be using drag force to also change the initial curve that we get with just gravity, so it can project the curve so it can be similar to the observed curve. So here's my tracker video. Here we have I angled it to a slight angle so it can be right in the middle. And here's the cloth falling down. And the one I used to measure the height of it is using the meter stick provided in the video, and I put it as 1 meter. And here we see the slight curve, although it looks like a constant curve. So constant velocity curve, and here's the time and y direction of the y-axis. So here's the data I have compiled. So this is here are the same numbers. Although right here I have it starting at 0 and tracker has it starting at 0.133. They're both similar, but I had to start it a little bit to 0 because my glow script code didn't work that well. So here we have the curve. As I said, it looks like a constant velocity curve, and here we have the free fall without drag. And as you can see here, my code actually worked pretty well with it, but as you can see, it kind of like it kind of went off uh, because of the tracker and also where I put my data points when I was tracking the rack, the cloth coming down. As you can see, there's a little slightly disproportionality right here, and here's the one with drag. So there's there's a larger um difference here. As you can see here, this is my time constant, and also here's the height. And as you can see here, there's larger here than here, and the other one without drag. So if need be, if there's the need to like simulate the rag falling down, the free fall without drag embedded into it actually worked out better for me because there are certain points that they both actually equaled. And here are the same code as well. Here's the data here, and also the code here. This is the code for the without drag. As you can see, I have my j hat b is equal to 0, so we can say that there's no drag force, just only gravity for working upon it. Here's my weight force, which is the mass of the ball times gravitational constant, which is 9.8 meters per second, times j hat. And as you can see, F net equals W, and here's the momentum principle, which is the ball's velocity equals the final ball's velocity equals the initial ball's velocity plus F net over the ball's mass times delta t. And for delta t, I actually put as 0.033, which was the amount of seconds per frame. So that's why I have my delta t as 0.033. And it's the same here as well. I have the only thing that changes from here is that my B is different, and also my Fnet is slightly different because I added FD, which is the force of drag, which is negative B, which is the proportionality constants of the magnitude of the drag force times the velocity of the ball. How I found the proportionality constant was I just did a little bit trial and error, trying to find the equalizing numbers of my observed and also the coded one, so that they're both similarly equal, and it has like a smaller, uh, not that big of a difference. But as you saw, there was a larger difference compared to the one with the gravity. So what does which models, if any, predict terminal velocity? All three of them can predict terminal velocity, but the one with just gravity with no drag force will predict it a slightly better than the other ones, because my observed one can be used as well, but not to a greater degree. But the one that's coded that is without drag can predict terminal velocity slightly better than any of the three. What would the terminal velocity be in the case if so? What would the terminal velocity in this case will be the same or different from the same object initially dropped from rest? So if I throw something harder, if I threw the rag harder, it will get to a terminal velocity faster than if it was just dropped from the same height, because you add a force to it, and that force will add to the gravity's force that pulls down on the rag, and you'll just add a little bit more, and they'll make it get to its terminal velocity quicker. So that's the end of my lab, and thanks for watching.